What's new in the world of air conditioning and heat pumps? Well, today on our Dare to Compare tour, we'll discover several unique and patented manufacturing processes developed and engineered to make selling and installing our products as easy as possible. Let's get started. We're here with Rizik Ghaffari. How you doing, Rizik?
How are you?
Real
good to see you, Mark.
Rizik's the Vice President of Cooling Manufacturing. Rizik, give us a quick overview of this facility.
Sure, Mark. This facility started in 1982. This is a cooling facility. It makes condensing units and heat pumps. And we have 8 assembly lines. Start with the components here and there. Before you know it, the product is finished and complete and tested. And then we have the fabrication area, which is very equipment intensive. It's pretty neat to go and watch and see what we make out there.
Wow, well that all sounds very interesting. So tell me, what's the biggest thing that you've got going on here at this facility?
Well, let's go out and check it out.
Sounds good.
All right.
You weren't kidding, this press is big!
It is, Mark. This is a 1,200-ton press. This is the tip of the iceberg. It's 23 feet below the ground that you're standing on.
You're kidding me!
This machine here makes every single top and bottom for all our chassis sizes on the heat pump and the condensing unit. It's all being made right here. This is the heartbeat of the facility.
Boy, you're telling me, boy, that's a lot of stuff every year.
You can see the operator is just taking the parts and racking them up.
All right, take me, show me something new, because this is great.
Well, the next stop we're gonna do is we're gonna show you something huge, but it's rather small.
Hang on, now you're just trying to confuse me.
I know I am. Let's go to the 5mm fin press and watch that.
Let's check it out.
All right. Okay, Mark. Now, by the time we made it here, we already have ran about 10,000 pounds of steel on that 1,200-ton press.
That's amazing. But hang on a second. Back over there, you were telling me that you had something really big but was really small, and I'm still a little confused about that. So you're going to have to explain that to me.
Let me explain it. I have the answer right here.
You got it there.
This is what I mean. It's something huge but rather small. This is a 5mm copper. We call it the hairpin. This is a 3/8. You could see the size difference between the two. This is a huge improvement, because what we did when we went to this smaller tube, we optimized the design for R410A. At the same time, we increased the pressure burst test by 20%. Believe it or not, the smaller, the stronger. That's how we were able to take that 2-ton unit and make it smaller than 1.5-ton unit, just by going to that.
Wow.
So you know, Mark, we have 4 pending patents in 13 countries.
Okay, Rizik, earlier you were telling me about the 5mm tubing that you use and that the precision that's required in the manufacturing processes of that. Now, if I'm not mistaken, this machine behind us has something to do with that process, so why don't you tell me something about that?
You're onto something, Mark. You're absolutely right. If you look at this process in here, what you're doing is you're taking the manifold and you're putting the stems or the little feeder tubes right onto the manifold. At the same time, you look and you see you have green hoses on there.
Right.
Those green hoses are hydrogen purged. They purge all the copper on the inside to make sure we don't have any contamination and keeps the copper clean on the inside. And once everything is installed and ready, you have also small little braze rings on there to make sure the amount of the solder is always consistent. So at the end, when you have a perfect product, it comes all the way around and it's always consistent.
So you've got hundreds and hundreds of the same piece coming out exactly the same.
Taking the human element out of it. All you have to do is load into the fixture. That's all you do.
All right, Rizik, we looked at the detail and the quality controls that you put into all of your component parts, and now here we are at the assembly line.
In a zero defect, there are 3 main principles. The first one is, are we conforming to the standard and the quality requirements we have, which is defined by the customer, okay? It feeds in from the customer. The second pillar in a zero defect, are we making sure we're preventing errors and mistakes before they happen? Let me show you an example. Okay. An example of error proofing is this screen right in here. This is one of the Visual Factory that tells you, and it matches the part with the bill of material to make sure our operators are not making a mistake. Another one is over there to my right, and this system is called critical component scanning. If you see over there, there's a green check mark right now, and it went away. That tells you you had the right combination based on the bill of material, based on the right part number you're running down the line.
So while you're working, all you have to do is give a quick look up, know that you're good, and it goes on, and you move
Take
to the
the
next.
human factor out of it.
You make the move to the next assembly.
Absolutely.
What next?
And then what's next is every single unit gets 100% tested. Even though we have that high quality requirement, it doesn't mean that we do some and skip others. As a matter of fact, every single unit gets hooked up, and what we do, we stabilize the pressure inside the system. Then we apply voltage to the system, and we check for high power. From that, it turns on the compressor at a low voltage to make sure your compressor comes on at the lowest voltage possible. Then your fan comes on, the motor turns on to make sure those two combinations are working, and it's looking for voltage and amperage. If you look on the units, you have an accelerometer where it measures the vibration on the unit. So while the unit is running, it makes sure we don't have any loose components, something didn't get tightened. We do a gross leak check on a braze line. We do a pressure decay, which is a gross leak check. Then after it passes those 200% check inspection, it goes through that booth right over there, and it checks for the fine little leaks. Now you've seen, Mark, all of our processes, all of the systems, and now this is why we dare to compare our potential customers to come and see us and put us against any of the competitors or the product out there.
Once again, we've witnessed a lot of processes and procedures that ensure the highest levels of quality and performance on the manufacturing line. But to really appreciate everything that they've got going on here, you need to come and take a Dare to Compare tour in person.